The Levitating Water Experiment, Defying Gravity with Science. What if I told you that you could make water float in midair, defying gravity, using just a simple household item? No magic, no tricks, just pure physics. Today we were going to perform an experiment that seems impossible at first glance, levitating water upside down. How does this work? And what surprising force is strong enough to hold water in place against gravity? Let's find out. Introduction to the science. At first glance, it seems like gravity should always win. Pour water into an open cup, turn it upside down, and of course it falls out. But there's an invisible force at play here, one that is strong enough to hold the water in place. Air pressure. Our atmosphere is constantly pushing down on us with a force of about 101,000 pascals. That is like having a small car pressing down on every square meter of your body. Normally, we don't notice it because air pushes equally in all directions. But when we manipulate it just right, we can use air pressure to do some incredible things, like keeping water suspended in an upside-down glass. Step-by-step experiment. Here's how you can try this at home. 1. Gather your materials. You'll need a glass, a piece of stiff cardboard, or a smooth plastic lid, and some water. 2. Fill the glass completely with water, right to the very brim. No air bubbles should remain inside. 3. Place the cardboard over the top, making sure it seals the glass tightly. 4. Now, the big moment. Hold the cardboard in place, quickly flip the glass upside down, and then let go of the cardboard. What happens? If you did it right, the water stays inside the glass, seemingly defying gravity. So why doesn't the water fall out? The secret lies in the balance of forces. Air pressure from below. The cardboard prevents air from entering the glass, so the only pressure pushing upward on the cardboard is from the atmosphere outside. Water's weight pulling down. The water tries to fall, but as it does, it creates a tiny vacuum, a low pressure zone inside the glass. The equilibrium. The outside air pressure is strong enough to push up on the cardboard, counteracting the weight of the water. As long as the upward force from air pressure is greater than the downward force of the water stays in place.